Alright, now we're going to talk about chain rule with trig functions. So suppose we have a function that is a composite of two functions, such as f of g of x, or another way you could write that is with a little circle, f of g of x. And f of x is a trig function. Then the following rules are true. Again, the derivative of sine is cosine. So if we have sine of some sort of function, then the derivative is going to be cosine of the function times the derivative of the function. So again, if you want to think about, we talked about the M&Ms, this is the derivative of the shell times the derivative of the chocolate. Derivative of cosine is negative sine, and then you have to take the derivative of the inside of g of x and so forth. So let's go, your best bet is just let's look at several examples. Alright, number one, if y is equal to sine of 3x, then y prime is equal to, well, my outside is the sine, the inside is this linear function 3x, so my shell is sine, my chocolate in this case is 3x, so I have to take the derivative. So the derivative of my shell is going to be cosine. And I need to keep my chocolate, because remember, my chocolate hasn't melted yet. We're just melting the shell. And then I'm going to take the derivative of once the shell is melted and the chocolate's now all that's left, take the derivative of the chocolate. In this case, it's 3x. The inside is 3. And so a lot of times if you'll see this written, they'll write it as y prime is equal to 3 cosine of 3x. Alright, number two, find the derivative if y is equal to 5 cosine of 9 minus 2x. Again, this 5 cosine is my shell, and 9 minus 2x is my chocolate. And so let's go ahead and take our derivative. So y prime, so dy dx is equal to, so the derivative of cosine is negative sine, so we have negative 5 sine, and then I'm just going to rewrite my chocolate, 9 minus 2x, and then I'm going to multiply it by the derivative of my chocolate, in this case negative 2. And so if you're looking at a multiple choice question, they're going to rewrite this as negative, let me see here, positive 10, so negative 5 times negative 2 is positive 10 sine of 9 minus 2x. Number three, find the derivative of sine of negative 6x over cosine of negative 6x. You could, if you wanted to, you could use the quotient rule. However, I hope you recognize that sine over cosine, notice that I have the same chocolate. My chocolate of that negative 6x is the same. And so sine over cosine is tangent. So I could have written this as equals to the derivative of tangent of negative 6x. And I only can do that when my insides are the same. If they were different, then I would have to use the quotient rule. But since they're the same, I'm just going to say, well, sine over cosine, I'm going to use my little pre-calc trig trick and say, hey, that's just tangent. So let's go ahead and take our derivative. So again, our shell is the tangent. Our chocolate, the inside, is at negative 6x. So this is going to be equal to the derivative of tangent is secant squared. And we're going to rewrite our chocolate, the inside, negative 6x. And then we're going to multiply it by the derivative of our chocolate, which is negative 6. And so if you're going to see this on a multiple choice, they're going to rewrite this as negative 6 secant squared of negative 6x. Number 4, find the acceleration if the velocity is equal to v of t is equal to negative secant squared of t plus 7. So again, the derivative of velocity is acceleration. And so let's rewrite this, because this little 2 right there is going to screw you guys up. And so if I rewrite this guy, he becomes is equal to, so I have 2 negative secant of t plus 7s being multiplied. So I have 2 of these guys. That's what this little 2 means. So I have negative secant of t plus 7, and that's being multiplied by another negative, secant of t plus 7. So if I have 2 things being multiplied together, essentially what I have is I have negative secant of t plus 7 squared. And so for this one, this is what we talked about earlier. This is going to be our peanut M&M. And so we have the derivative of the outside. Well, the outside is this right here. That's my shell, is the square. The derivative of my chocolate is the negative secant. And the derivative of my peanut is at t plus 7. So I have to take the derivative of each. So a of t is equal to, well, the derivative of the blue, of the shell, is going to be 2 times, in this case it's going to be the chocolate and the peanut, so 2 times negative secant of, that's my chocolate, and then my peanut. So far all we've done is we've melted off the chocolate, or melted off the shell, so now we just have the chocolate and the peanut. So next we need to take the derivative of our chocolate. Well, the derivative of secant is secant tangent, so we have negative secant of my peanut, tangent of my peanut. So let's go ahead and fill in the peanut. And then we're going to multiply by the derivative of our peanut. Well, in this case, the derivative of our peanut is 1. Derivative of t is 1. So if we put this all together, I have, let's see here, a negative, and a negative becomes positive. So this becomes positive. I have 2 secants. So if I put those together, I'm just going to square them. So this is going to be equal to 2, because it's not positive. I have 2 secants, so it will be secant squared of t plus 7 times tangent of t plus 7. Again, this is just to show you so you can be able to recognize on the multiple choice. On the free response, you're able just to leave it as it is. Number 5, find the derivative for x times sine to the third of 7x. So first of all, I hope you notice that I have the product rule. Here's the first, and here's the second. My second is kind of written kind of ugly. So if you want to look at it, my first is x. My second is written kind of ugly. Again, I have that little third, so that means I have sine of 7x times sine of 7x of sine of 7x. I have that 3 times. And so instead I could write this as sine of 7x raised to the third. That's my second function. So when I take the derivative of this guy, I'm going to use my product rule. So the derivative of my first is 1 times my second. So we can just go ahead and write, I'll put this in brackets so you can see it. Sine of 7x to the third plus the first. Now the derivative of the second is pretty ugly because again I have a chocolate, I have essentially a peanut M&M with shell, chocolate, and then finally the peanut. So here is the shell that raised to the third. My chocolate is the sine x, and finally my peanut is that linear function of the 7x. So let's multiply by each. So the derivative of my shell is going to be 3, and this is going to be squared. And then I'm going to have my chocolate and my peanut. So sine is my chocolate, 7x is my peanut, and then I need to take the derivative of my chocolate, which is going to be cosine. Again, my peanut hasn't been touched yet. I haven't crunched my peanut. And then finally, I'm going to take the derivative of my peanut, which is going to be 7. And so in this case, I'm going to leave it because it's going to be incredibly ugly to simplify. Finally, number 6, find h prime if h is equal to -1 over the square root of tan of 10x. So if let's rewrite this. So we have negative tan of 10x raised to the -1/2. Well, my outside, again, my shell is the -1/2. My chocolate is the tan x. My peanut, excuse me, is the tangent. My peanut is the 10x. So when I take my derivative, oops, derivative of my shell, so -1 times 1/2 is a +1/2. And this whole thing stays the same, so -1/2 minus 1 is -3/2. And I still have my chocolate and my peanut intact, so I'm still going to have my chocolate, which is tangent, and my peanut, which is 10x. And then I'm going to have the derivative of my chocolate is derivative of tangent is secant squared of my peanut, and then finally derivative of my peanut. So all these is today earlier we talked about their triple, and so now we're going to be practicing on how to do all our stuff, our plain M&M and peanut M&M using trig functions.